Okay, good day everyone. So welcome back again to our channel. So in this video, we're going to solve some problems about design of bolts and screws. Okay, but before we proceed with the problems, here are some of the important equations. So dito meron tayong pang set screw. So from machinery's handbook, ito yung ilang mga formula. Then for bolts, nandito yung from Valance saka kay Fairs. Okay, so nakasama rin siya. So kapag yung problem may mga given halimbawa C, so automatic gagamitin natin si balance. Otherwise, kung ang given ay yield strength, so gagamitin natin si Fairs. But mostly dun sa mga problems, si Fairs or yung formula ni Fairs yung ginagamit. And then next, useful formulas for yung power screws. So ito yung ating power screw. So ginagamit siya pang lift or pang move ng load. So maraming application ng power screw. Ito sa lang ito sa mga yon. Okay, so ang sinasolve natin dito mostly ay yung torque or yung force na kailangan para i-lift yung load. So yung force na yon, ma-analyze natin kapag kinonsider natin yung isang thread. Okay, and then sa thread na yon, doon natin ilalagay yung load na yung weight, and then yung applied force Q, and then yung ating resultant reaction due to normal force and friction force. Then from that, we can draw a force triangle relating the resultant reaction, the weight, and the force Q. Okay? Take note na yung torque dito ay Q multiplied by mean radius ng ating screw. So, ang mean radius nandito, which is yung kalahati lang ng D sub M. Kaya yung torque natin dito, equal yan sa Q multiplied by dm over 2. And then dito, yung Q, palitan lang natin siya in terms of weight and the angle. So, gamit yung ating tangent, masasolve natin yung Q. So, itong formula na to, pang lift lang ng load or tighten ng screw. So, meron din tayong ibang formula, yung loosen, okay? Pero sa loosen or lower yung load, so meron tayong i-consider dyan yung angle beta at yung angle lambda. So, yung beta dito, angle of friction, then lambda, of course, our lead angle. Okay, so if the lead angle is greater than beta, so ito yung ating formula. And then kapag yung tangent quantity lambda minus beta, in-expand natin, ito lang siya. So, no need to memorize actually ito as long as alam nyo to. Okay, similar lang dito. Pwede nating expand yung tangent quantity beta minus lambda. So, dito naman sa case na to, yung ating lambda ay mas maliit sa beta. Again, doon sa nauna, pinalitan lang natin yung force Q in terms of weight tsaka yung lambda and beta. So, ganun din dito. So, yung torque, yun pa rin yung Q multiplied by dm over 2. And then yung Q, solve natin siya in terms of weight and lambda and beta. Okay, next formula for the torque required to overcome collar friction. So yung point of application nito, nasa mean radius natin. Okay, yung pagitan ng outside radius sa inside radius, kumbaga nandito yan. So yung radius ng collar, so yung R sub C. So ang top view nito, kumbaga, ito yung outside, ito yung inside radius. So nandito yung torque. Yung force na to multiplied by yung R sub C. Okay? And then next, for the total torque required to operate the power screw, pagpaplasin lang natin yung torque dun sa collar at saka dun sa torque para dun sa screw. Next, output power of screw. And so ito ay force multiplied by velocity lang. So magiging force natin ay yung mismong weight and then yung velocity ng screw. Yung kung yan ay pataas, yung velocity niya pataas. So, may formula tayo pang V or for velocity. So, bali yung velocity natin, ito siya. So, rotational speed multiplied by the lead. So, rotational speed, yan ay pwedeng revolution per minute. Meron din tayong input power ng screw. So, sa input power, gagamitin lang natin yung total torque. Okay, so from the formula 2 pi Tn. Okay, so substitute lang natin yung total torque dito. Then lastly, for the efficiency. Okay, ito yung para sa square thread and then for acme. So, ang difference lang ng dalawang to ay yung cosine phi. Okay, yung phi, alam natin, yan ay 14.5. Okay, so let us solve problems. An eye bolt is lifting a block weighing 350 pounds. The eye bolt is of sa 1040 material with SU 67 KSI and SY 55 KSI. What is the stress area in square inches of the bolt if it is used under the unified course series thread? So, ang given natin ay bolt, meron siyang load na 350 pounds. So, hahanapin natin yung stress area. So, gamit yung ating formula from the table of pairs. So, ang isusolve natin dito ay yung A sub S. Substituting FE. So, ang FE natin ngayon dito ay yung 350 pounds. And then yung SY, so ilagay natin 55,000. So, masosolve natin yung A sub S dito na 0.1134 square inch. Okay, so next problem. Find the horsepower loss when a collar is loaded with 1,000 pounds, rotates at 25 RPM, and has a coefficient of friction of 0.15. The outside diameter of the collar is 4 inches, and the inside diameter is 2 inches. Okay, so ang given natin, W, yun yung 1,000 pounds, and then N, 25 RPM, and then yung given na coefficient of friction, since ang tinutukoy dito sa problem ay yung collar, so yan ay F sub C. Okay? And then meron tayong outside diameter ng collar. So let us denote that as D sub O, 4 inches, and yung inside diameter ay 2 inches. So dito sa ating figure, radius lang yung nilagay natin. So understood na yung radius natin dito ay yun yung mismong DO or D sub O divided by 2, and then same dun sa R sub I. Okay, so D sub I over 2. So, ang hinahanap natin kung titignan natin sa problem, so horsepower loss, saan ba natin isusolve ito ngayon? So, since ang tinutukoy niya ay doon sa collar lang, so, ang masasolve natin doon ay yung torque ng collar. So, since power yung hinahanap, gagamitin natin yung formula ng power na 2 pi Tn. Wherein yung torque dito, yun na yung torque sa collar. And then, let us denote yung unknown na P sub C. So, weight given, friction, F sub C, yun yung 0.15, and then R sub O, saka R sub I, or yung D sub C. So, masasolve natin yung mga yan based dito sa DO saka DI na given. Okay, so it's up to us kung paano natin isasolve yung torque based dito. So, yung D sub O saka D sub I kasi, pwede natin gamitin dito. Okay, so D sub C. Kunin lang natin yung mean ng dalawang to, yun na yung D sub C. So, solution. So, let us solve first for the torque. So, let us use this formula, but we are going to use D sub C, wherein that is only the average of these two. So, kaya magiging ganito yung ating equation. And then, substituting DO and DI, and W, and then yung F sub C. So, masasolve natin dito yung torque, which is equal to 225 inch-pound. So, therefore, we can now substitute this torque to our formula. Then, let us convert yung inch sa feet para magamit natin yung ating conversion factor na 33,000 foot-pounds per horsepower minute. Pero syempre, pwede rin kayong gumamit ng ibang conversion factor. So, this is equal to 0.089 horsepower. Next problem, compute how many 3/8-inch diameter seat screws required to transmit 3 horsepower at a shaft speed of 1,000 RPM. The shaft diameter is 1 inch. So the required here is the number of set screw. Okay, so the given, we have the diameter of a set screw, 3/8-inch, and then the power transmitted by the shaft, 3 horsepower. Then we have an RPM of 1,000. So the shaft diameter is 1 inch. So using our formula for the number of set screw, so meron na tayong power ng shaft. So 3 horsepower. And then yung power ng set screw, we can use the formula from the machinery's handbook, that is quantity D, so 1 inch yung ating shaft diameter, and then RPM, and then shaft diameter is 2.3 over 50. Okay, so this is equal to, so power of the shaft, so 3 horsepower, then over the power transmitted by single set screw. So take note that this power is for a single screw. So we can use the unit for this quantity as horsepower per screw. So substituting all given values, we can solve the number of set screw here. So this is equal to 1.43. Therefore, we can say that the total number of set screws needed are 2. Next problem, what is the frictional horsepower acting on a collar loaded with 100 kilogram weight? The collar has an outside diameter of 100 millimeter and an internal diameter of 40 millimeter. The collar rotates at 1000 RPM, and the coefficient of friction between the collar and the pivot surface is 0.10. So again, the required here is frictional horsepower. Since we are talking about dun sa collar, so yung formula natin ngayon ng power ay 2 pi Tn ulit. Wherein yung T, yun yung torque required to overcome collar friction. So let us denote this power again as P sub C. And then again, we are going to use this formula to solve for the torque. So D sub C. So yung D sub C natin dito, alam natin equal siya sa average ng inside sa outside diameter. Kaya yung formula natin maging ganito na for torque. So, substituting all given values, but take note ito ay naka 100 kg, pwede natin i-convert to ng Newton. Para yung power na masasolve natin dito ay naka kilowatts or watt. Okay, so let us convert this kilogram to Newton. So, 9.81 Newton per kilogram. So, W is 980, and then F sub C is 0.15. Then for our diameter, so we have 100. Then inside diameter is 40. So ito ay naka-millimeter. So convert na rin natin siya sa meter. So divide lang natin ito ng 1,000 millimeter. So this is equal to 5.145 Newton meter. So therefore, our power will be, so substitute 5.145 to our formula, to kay Tn. Our RPM here or N is 1,000 revolution per minute. So let us convert minute to second. So 1 minute over 60. So ang power natin dito ay equal to 538.78. So this is watts. But take note that the requirement here is frictional HP. So therefore, let us convert watts to horsepower. So we have 1 horsepower is equal to 746 watts. So this is equal to 0.722 horsepower. So next problem, a 2.5 double square thread. So take note, double square thread. And then yung 2.5 dito, automatic yun ay outside diameter. That's why meron tayong D, 2.5 inches. So square thread, so kung babalikan natin yung ating lecture, ito yung ating figure for square thread. So mamaya malalaman natin kung ano yung purpose nitong figure na to. So with 2 thread per inch is to be used. So meron tayong given na 2 thread per inch. So let us denote yung thread per inch as TPI. So 2. The frictional radius of the collar is 2 inches. So meaning, yan na yung ating R sub C. Okay? And the coefficients of friction are 0.10 for the thread, so that is F, and 0.15 for the collar, so that is F sub C. The velocity of the knot is 10 feet per minute. So meron tayong given velocity, so 10 feet per minute. For a lifting load of 4,000 pounds, find a lead angle. So let us denote that as lambda. So para related doon sa ating figure. Then B, the torque required to turn the screw, or that is our T. The torque required to overcome collar friction, so that is T sub C. And then for letter D, the efficiency of the screw. And then for letter E, the power input of the screw. Ngayon, para dun sa lambda, ang formula lang naman dyan, yung tangent. No? Tangent lambda is equal to yung lead over pi d m. Okay? So let us solve lambda. Again, yung ating formula from tangent lambda is equal to lead over pi dm. So yung figure natin para dito sa lambda, so ito na yon. Okay? So meron tayong lead na formula which is yung L is equal to 2P. This is for double thread. Pero wala tayong pitch. So yung pitch naman dito, alam natin 1 over thread per inch. Okay? But how about yung ating mean diameter? So meron tayong D. Paano ba natin ngayon isosolve yan? So pagdating doon sa ating figure, so ito yung square thread. Kumbaga yung diameter dito, na outside diameter, ito yon. Yung inside diameter, ito. Okay? So kung titignan natin sa side view, ito yung outside diameter, yung D. And then yung D sub R, yun yung inside diameter. Now, how about yung ating D sub M? Okay? So, yung ating mean diameter. So, meron tayong outside diameter or yung 2.5. So, lagyan natin dito D sub O or simply D. So, yung D sub M ngayon na kailangan natin kung isusolve natin siya in terms of D. So, yan ay simply D minus H. Okay? So, ito kasi, yung ating DM. Yan. So, yung mula dito hanggang dito sa point na to, yun yung H. And then yung kalahati, of course, H over 2. So, kumbaga dito, yung D, equal yan sa DM plus dalawang H over 2. Or simply, this is plus H. Okay? So, DM plus H. So, therefore, DM is equal to D minus H. So, let us continue. So, ang lead natin dito equal to 2P since double thread. And then for pitch, so that is 2 multiplied by 1 over thread per inch. Okay? Which is 2. So, 2 thread per inch. Kaya ang lead natin dito ay 1. Then for DM, so D minus H. So, ang D ay 2.5 inches. Then minus yung ating H. So, according to Khurmi, so that is 0.5P. But for fairs, that is 7 over 16P. Okay? So, ano ba yung H na gagamitin natin dito? Okay? So, pagdating sa board exam, pwede natin gamitin pareho and then i-check natin yung choices dun sa questionnaire natin kung saan yung malapit yung ating sagot. So, ang hinahanap kasi dito ay yung lambda. Okay? So, ang mahirap kasi, kapag ginamit yung dalawang to, nandun pareho yung sagot. Pero most probably, ang gagamitin ng examiner natin ngayon ay yung kay Fairs. Kasi yung kay Khurmi ay Indian. So let us use yung H na 7 over 16p. Okay, so yung H natin dito ay 7 over 16p. This is from Fairs. Again, yung ating P, yun yung 1 over thread per inch. So 7 over 16 multiplied by 1 over 2. So ang mean diameter natin therefore ay 2.28125. So this is in inch. So using now our formula for lambda, okay, so let us solve lambda. So lambda is equal to arctangent of the lead. So ang lead natin kanina 1 inch, then pi dm. So ang dm natin dyan ay 2.28125. So this is equal to 7.94 degrees. Ngayon, pagdating sa board exam sa choices, kung ano yung pinakamalapit na sagot, yun ang kukunin natin. So next unknown is torque. So using our formula for the torque of the screw, so ang weight natin dito ay equal to 4,000 pounds. dm, yun na yung na-solve natin dun sa letter A kanina, and then lambda, meron na rin. Okay, and then yung F, 0.10. So, kompleto lahat. So, substitute lang natin lahat dito. So, ang weight natin ay 4,000 pounds. Then, yung DM kanina ay 2.28125. Then, yung ating lambda, 7.94. Then, yung coefficient of friction, 0.10. So, over 1 minus 0.10 multiplied by tangent of 7.94. So, ang torque natin dito ay 1,108.05 pounds itong weight. And then inch itong dm. So, inch pound yung ating unit. Next unknown for letter C. So, this is for T sub C. Since given yung R sub C, so ito yung gagamitin nating formula. So, substitute lahat ng given. So, ang weight natin ay 4,000 pounds. 0.15 yung F sub C and then yung R sub C ay 2 inches. So, this is equal to 1,200 inch pound. So, next unknown, letter D. So, that is efficiency. So, ang formula na gagamitin natin ay ito. Okay? So, yung lambda, meron na tayo dun sa previous solution. Yung coefficient of friction, meron na rin tayo. Then, yung mean diameter, meron na rin tayo niyan. And then, ang wala tayo dito ay yung D sub C. Pero since meron na tayong R sub C, so times 2 na lang natin to. So, substitute yung ating lambda, yung F, and then D sub C, tsaka D sub M. Take note, yung D sub C dito ay twice lang nung radius kanina. So, that is equal to 4 inches. So, masasolve natin yung E dito na 0.2757 or this is equal to 27.57%. So, multiply lang natin ito ng 100%. Then, last unknown, P sub I. So, our formula for P sub I is equal to 2 pi, then the total torque multiplied by N. So, yung total torque natin dito ay yung sum ng T tsaka T sub C. So, ang total torque natin dito ay 2308.05. Then, how about yung N? Wala tayong given RPM. So, meron naman tayong velocity. So, solving for N, okay, gamit yung V from the formula for velocity, which is yung ating L multiplied by N. So, dito galing yon. So, velocity is equal to rotational speed multiplied by N. So, ang rotational speed natin, yun na yung RPM. So, let us denote yung RPM na N na lang instead na rotational speed. Okay? So, yung ating N, therefore, is equal to V over yung lead. So, velocity ay 10 feet per minute. So, ang lead natin dito kanina ay 1 inch. Okay? So, ito yung solution dun sa letter A kanina. So, nandito yung ating lead. So, 1 inch. So, since hindi consistent yung unit, convert na lang tayo. Okay? So, multiply natin to ng 1 foot per 12 inch. Take note, yung lead ay naka-per revolution. So, magiging unit natin dito ay revolution per minute. So, this is 120. So, therefore, using our power formula, so 2 pi Tn again. So, 2 pi multiplied by the total torque. So, that is 2308.05 inch pound multiplied by 120 revolution per minute. So, since naka-inch pound tayo dito, pwede natin itong i-convert ng feet. So, dito na lang natin ilagay yung 12 inch per foot. And then, using our conversion factor, so 33,000 foot-pounds per horsepower minute. So, masasolve natin dito yung power na 4.39 horsepower. So, this is our P sub I. Okay? So, next problem, a single-threaded trapezoidal metric thread has a pitch of 4 mm and a mean diameter of 18 mm. It is used as a translational screw in conjunction with a collar having an outside diameter of 37 mm and an inside diameter of 27. The load is 400 kg and the coefficient of friction is 0.3 for both threads and collar. So find collar torque, so that is T sub C. Letter B, the required torque for thread, and then for C, the total torque. So yung given thread dito, walang sinabi kung acme or square. Pero kung nakalagay dito, trapezoidal, so meaning that is our acme thread. Kaya yung formula na gagamitin natin dito for the torque dun sa ating screw ay ito. Okay? So ito lahat ng formula na kailangan natin. Okay? So unahin natin isolve yung T sub C or yung torque dun sa collar. So ito yung ating formula since ang given natin ay DO tsaka DI. Okay? Dun sa ating collar. So yung ating weight ay 400 kg. Kung gusto natin gawing Newton, okay lang din. So wala namang required na unit ng torque dito. Yung F sub C, parehong 0.3 or kapareho ng F. And then D sub O tsaka D sub I, so 37 and 27. So substitute lahat ng value. Masosolve natin yung T sub C na 1,920. So ang unit, ito ay naka-kilogram and then millimeter to. So kilogram, millimeter. Kung gusto natin gawing Newton, millimeter, okay lang din. So multiply lang natin ng 9.81. So wala namang required unit yung letter A. So ito na yung ating sagot for T sub C. Then for letter B, for torque, for acme thread. So ito yung ating formula. D sub M given na, so 18 mm. Then for phi, so that is 14.5 degrees. Okay? So let us solve tangent lambda. Okay, so instead na lambda yung solve natin, yun na lang tangent lambda. So para mas madali yung pag-solve natin. So yung lead natin dito, pag single thread, yan ay equal sa P. Okay, so yung P natin ay 4 mm. And then yung ating mean diameter ay 18. So yung tangent lambda ay equal to 0.0707. So ito, pwede pa nating dagdagan ng decimal places. Okay, so substitute natin lahat dito sa ating formula for T. So yung torque natin dito sa letter B ay 1,400.74 kilogram millimeter. Then last letter C. So the total torque. So i-add lang natin tong dalawa. Okay, so total torque is equal to 1,400.74 plus 1,920. So this is equal to 3,320.74 kilogram millimeter. So that's all for this video. Thank you for watching.